This lesson is about measuring segments. The objective is to find and compare the lengths of segments. The first postulate that we have is the ruler postulate. And the ruler postulate says that every point on a line can be paired with a real number. This makes a one-to-one correspondence between the points on the line and the real numbers, which are also called coordinates of the points. So in the diagram, we have point A, which is the uppercase A, that's paired with real number, which is the coordinate lowercase a. And we have point B, which is paired with coordinate, the real number is lowercase b. Now the distance between 2 points is the absolute value of the difference of their coordinates. This value is also called the length of the segment between the 2 points. In postulate 6, this is the segment addition postulate, and it indicates if 3 points, A, B, and C, are collinear, so they're on the same line, and B is between A and C, then AB, the length of segment AB plus the length of segment BC is equal to the length of segment AC. So if you picture this, we have A, B, C, the length of segment AB plus the length of segment BC is going to be the length of the larger segment, AC. When numerical expressions have the same value, you say that they're equal. But if you're talking about segments, 2 segments that have the same length, then you say that they are congruent. So there's a difference between saying that 2 things are equal and 2 things are congruent. If 2 things are equal, like the length of AB and the length of segment CD, look at in the example in the picture above it, the length of segment AB is 1 inch, the length of segment CD is 1 inch. You're talking about values, numeric values, measurements that you can say are equal. But when you're talking about the segments themselves, segment AB and segment CD, then you have to say that segment AB is congruent to segment CD. And you use congruence markings to show that. Those 2 markings indicate that those 2 segments are congruent. The next definition is a midpoint of a segment. So a midpoint of a segment is a point that divides the segment into 2 congruent segments. Now a point, line, or ray or other segment that intersects a segment at its midpoint is said to bisect the segment. That point, line, ray, or segment is then called a segment bisector. So let's look at the examples on the right. Problem 1 is measuring segment lengths. And we're going to use the ruler postulate to do this. So how do you read the question? That's the first thing. You need to know what the question is asking. You read this question, what is the length of segment CD? So it's asking for the length of segment CD. So the length of segment CD, we'll put 2 letters together with no segment symbol over the top of them. That indicates the length of segment CD. We're going to use the ruler postulate and see what values are associated with C and D. C is associated with 2, the real number 2, and D with the real number coordinate 10. So the absolute value of 2 minus 10 is the absolute value of -8, which is a +8 for the distance or length of that segment. We could have also put the values in the other way. We could have said that it was a 10 minus the 2, which would be the absolute value of 8, which is 8. Either way, you're going to get a distance or a length of 8. Problem 2 is using the segment addition postulate. It says if the length of segment LN is 32, what are the lengths of segment LM and the lengths of segment MN? So here I'm going to put on the drawing that it's given that the length of LN is 32. So I'm going to put that on the diagram. So according to the segment addition postulate, we have the length of segment LN plus the length of segment MN is going to be equal to the longer segment, which is LN. Now we can substitute values into this. The length of LM on the diagram is 3x plus 8. The length of MN is 2x plus 4. And LN is given to us in the problem as 32. So combine like terms. 3x and 2x is 5x. 8 and 4 is 12 equals 32. Subtract the 12 from both sides. 5x is equal to 20. Divide both sides by 5. X is equal to 4. That's not what the problem's asking for. It's asking for the length of LM and the length of MN. So the length of LM from the diagram is 3x plus 8, which is 3 times 4 plus 8, which is 12 plus 8, which is 20. The length of MN in the diagram is 2x plus 4. Substitute the 4 for the x. 2 times 4 plus 4 is 8 plus 4, which is 12. And that checks out because if you add those two together, 20 plus 12 is 32, and 32 is the length of the longer segment, the LN, the whole segment. Problem 3, we're comparing segment lengths. The question is, are segment AD and segment BE congruent? Well, to determine if they're congruent or not, you have to find the length of segment AD and the length of segment BE and determine if they are equal lengths, then they are congruent segments. So let's find the length of segment AD. That's going to be the absolute value of the coordinates of A and D. Note that the scale is going by 2's. So A is a -6 and D is 10. So a -6 minus 10, absolute value of that is absolute value of -16. So the length is a positive 16. The length of segment BE, look at the real value that's associated with B, the coordinate is 2, and the value that's associated with E is 14. So we have a -2 minus 14, the difference between those two coordinates. Absolute value of -16 is a positive 16. So since AD and BE are equal lengths, the answer is yes. AD is congruent to BE because the length of AD is equal to the length of BE. The last problem is using a midpoint. And it tells us that S is the midpoint of RT. So that tells us that, by the definition of a midpoint, that it divides it into two congruent segments. So it wants the length of RS, the length of ST, and the length of segment RT. So the way you would set this up, by definition of a midpoint, if S is the midpoint, then that means that segment RS is congruent to segment ST. By definition of congruent segments, that means the length of segment RS is equal to the length of segment ST. Now I can substitute. The length of segment RS is 7x minus 3. The length of segment ST is 3x plus 1. Now you can solve that for x. Subtract the 3x from both sides, gives you 4x. Add the 3 to both sides, gives you 4 on the right. Divide both sides by 4, and x is equal to 1. So now we need to substitute this back into find our lengths. The length of segment RS, according to the diagram, is 7x minus 3. Substitute in the 1 for the x, so 7 minus 3 is equal to 4. Then we can substitute the x into the 3x plus 1 to find the length of segment ST. But since we know that this is a midpoint and it divides it into two congruent segments of equal length, we could go ahead and take that value and say that ST is equal to 4. Wouldn't be a bad idea to check yourself and plug in the 1 to see that 3 times 1 plus 1 is 3 plus 1, which is 4. Now RT is the whole segment, and it's going to be 2 times the length of one of the segments, either RS or ST, either one, because it's bisected. It's in two congruent halves. So you can double that, double the length of either one of those, which is 2 times 4, and that gives you a length of 8 for the length of segment RT.